In this video, we will learn how to find out the profit maximizing level of output from the given demand and cost function. The question is, given P is equal to 20 minus 3x is the demand function, where P is the price, x is the output, and C is equal to 3 plus 2x square is the cost function. We have to find out the profit maximizing level of output. Options are being given, we need to find out the correct option. Okay, so we are being given the demand function as P is equal to 20 minus 3x. This is our inverse demand function. Also, we are being given the cost function as C is equal to 3 plus 2x square. Okay, now we know that for profit maximization, let me write it here. For profit maximization, the condition is that we equate the marginal revenue with the marginal cost. Okay, you know what is meant by marginal revenue. Marginal revenue is the change in the total revenue due to the change in the output, and similarly marginal cost is the change in the total cost due to the change in the level of output when one more unit of output is produced. So to find out the marginal revenue, first we need to find out the total revenue. Total revenue, as we know, it is equal to the price of the product times the units of output produced. That is price into output. Since output is being denoted by x, let me write it here, x. Okay, so P is being given as this very function, so let me write in place of P as 20 minus 3x. To this I need to multiply by x. This will give us the total revenue. So total revenue is equal to, so this x is multiplied to each of these terms, it becomes 20x minus 3x square. Now marginal revenue is simply the change in the total revenue, that is the derivative of the total revenue function with respect to the change in the output. Marginal revenue is how much total revenue increases when one more unit of output is sold. So the change in the total revenue due to the change in the output gives us the marginal revenue. Mathematically it means the derivative of this total revenue function with respect to x. Derivative of x in the first term is 1, so we are left with 20 minus derivative of x square is 2x by power function rule. 2 becomes coefficient, so let me write it here. We get 2 into 3x raised power 2 minus 1. So 20 minus 6x will be the marginal revenue. Okay, what about marginal cost? Symmetrically, marginal cost is simply the change in the total cost, that is the change in the total cost due to the change in the output, that is x here. That means the derivative of this cost function with respect to x, derivative of a constant is 0, so the derivative of first term is 0. Now derivative of x square is 2x, so 2 into 2 is 4x by power function rule, 4x. How do we apply power function rule? Let me explain it here also. So if we have x raised power n, its derivative is n times x raised power n minus 1, that is exponent becomes coefficient and exponent is subtracted by 1. Like if we have x raised power 5, its derivative with respect to x will be 5 becomes coefficient and the exponent is subtracted by 1. 5 minus 1 is 4. Okay, having said that, profit maximizing output will be that we equate marginal revenue with marginal cost. Marginal revenue is this function, so we have 20 minus 6x, we equated with the marginal cost, which is 4x. Now we need to solve for x, transpose it here, so we can 6x plus 4x is 10x, so 10x will be equal to 20, dividing both sides by 10, so dividing here by 10, here by 10, this gets cancelled, so x will be equal to 2. That means profit maximizing level of output will be equal to 2. Graphically we can also show it, that is if we show the output on the horizontal axis, marginal revenue and marginal cost on the vertical axis. We have this inverse demand function. It will be downward sloping, or it is our average revenue function. Now what is the marginal revenue function? This is our marginal revenue function whose slope is twice that of the inverse demand function. So let me draw it here. So this is our marginal revenue function. Marginal cost function is 4x, so it will be like this. Let me write it. This is our marginal cost function. Profit maximizing occurs at a point where marginal revenue and marginal cost functions intersect, that is at the output level of 2. Correspondingly, we can find out the profit maximizing price also here. So plug profit maximizing level of output into the inverse demand function, that will give us the corresponding price. So P will be equal to 20 minus 3. The profit maximizing level of output is 2, so we get price will be equal to 20 minus 6, so which will be equal to 14. So we got profit maximizing level of price is equal to 14 and profit maximizing level of output is 2. I hope I make myself clear in this video and you find out this video helpful. Thank you.